Hello, student. I am Dr. Pavitra Mohan Mahabatra. I am happy to see you at Pavitra Chemistry. Let us briefly revise the previous class. In the previous class, I discussed about what is formula, what are the steps for writing the formula of a compound. Next, I already discussed about the chemical equation. What are the different methods for balancing a chemical equation? Generally, there are four methods used for balancing the chemical equation. Number one is heat and trial method. Number two is partial equation method. Number three is oxidation number method. Number four is ion electron method. Among the four methods, I clearly explain about the heat and trial method by giving an example. Next, I already discussed about the algebraic method. It is a trick. This is all the examples given here. Look at that. A homework for you. You can do the homework. These are few equation. Your aim to balance this equation by using algebraic method. If you will try to balance this equation by heat and trial method, then it is very good. So try to solve this equation by both algebraic method and heat and trial method. In this class, In this class, I will discuss about the percentage composition. What is a percentage composition? How can you find out the percentage composition? Next, I will discuss about the type of chemical formula. Next, calculation of empirical formula and also calculation of the chemical formula. Let's move to know about the percentage composition. Take an example. Suppose I will take 100 grams of NH3. What I will give you? I will give you 100 grams of ammonia, that is your NH3. I want to know how much of nitrogen is present in 100 grams of NH3. You aim to find how much nitrogen, how much gram of nitrogen present in 100 gram of NH3, how much gram of hydrogen is present in 100 gram of ammonia, that is your NH3. This is called percentage of composition. Simply it is called percentage composition. So here I can define the number of parts by mass of the element in 100 parts by mass of the compound is called the mass percentage of that element. That means what percentage of nitrogen is present in 100 gram, that is called percentage of nitrogen. That is called percentage composition of nitrogen. Similarly, you can find the percentage composition of hydrogen. The mathematical formula to find out the mass percentage of an element is given here. Mass percentage of an element equal to total mass of an element divided by molecular mass of the compound into 100. This is the formula. By using this formula, you can able to find the percentage composition of an element. Let's explain this. Let me explain the percentage composition. Suppose move to the problem number one. Calculate the percentage composition of ammonia. That means it is necessary to calculate the percentage of nitrogen and percentage of hydrogen. At first, I will find out the molecular mass of ammonia. We know that the molecular mass of nitrogen is your 17 AMU. How can you prove that it is 17 AMU? Look at that. Here, one nitrogen atom is present. That means here I can write 1 into 14. Here, three hydrogen atom is present. So here I can write plus 3 into 1. That means here I can find 14 plus 3. That is your 17. So the molecular mass of ammonia is your 17 AMU. Now I will try to find the mass percentage of nitrogen. The formula is total mass of nitrogen divided by molecular mass of ammonia into 100. Total mass of nitrogen means here I can write 1 into 14. That means here I can write 14. Molecular mass of ammonia means I can write here 17. That means finally I can write mass percentage of nitrogen equal to 14 by 17 into 100. After calculation, you can find 82.35 percentage. 82.35 percentage. So here I can say that mass percentage of nitrogen is your 82.35 percentage. Similarly, if I want to find out the mass percentage of hydrogen, then you can write the formula like this. How can I write the formula? Mass percentage of hydrogen equal to total mass total total mass of hydrogen divided by molecular mass of ammonia into 100. Here 3 nitrogen atom is present. So here I can write total mass of hydrogen means I can write here that is your 3 by I can write here 3 by that is molecular mass of NH3 means that is 17. Then I can write here multiply with 100. That means mass percentage of hydrogen is equal to 3 by 17. 3 by 17 into 100. After calculation, you can find the value of mass percentage of hydrogen is your 17.65 percentage. Actually, this is the actual way to find out the percentage of hydrogen and percentage of nitrogen. Since in ammonia, here two type of atom is present. One is nitrogen, another is your hydrogen. So here we can find the percentage of composition of nitrogen and percentage of composition of hydrogen. Remember an important point, all the percentage composition of every atom must be equal to 100 when they are added. That means the sum of percentage composition of each element is equal to 100. So in the other way, I can also find the mass percentage of hydrogen by subtracting the mass percentage of nitrogen from 100. That means here I can write mass percentage of hydrogen equal to 100 minus 82.35 is equal to that is your 17.65 percentage. You can apply this formula, or you can subtract the mass percentage of nitrogen from 100. Then you can able to find the mass percentage of hydrogen. Next, take another example. Suppose I will take problem number 2. Calculate the mass percentage of urea. The formula of urea, you know that NH2 CO NH2. This is the formula of what? Urea. In urea molecule, you know that two nitrogen atom is present. This is the look at that. This is the formula of urea. Here one nitrogen atom is present. Here another nitrogen atom is present. Here four hydrogen atom is present. Here one carbon atom, one oxygen atom is present. Uh, the molecular mass of urea means I can find out like this. Here, since two nitrogen atom is present, so here I can write 2 into 14 plus how much the number of carbon atom is your 1. So here I can write 1 into 12 plus one oxygen atom is present. So here I can write 1 into that is your 16. Here 4 hydrogen atom is present. So here I can write 4 into 1. Now calculate. This is your 28. This is your 12. This is your 16. This is your 4. Now look at that. After addition, you can find that the value is your 60 AMU. Here we can conclude that molecular mass of urea is your 60 AMU. Mass percentage of nitrogen means total mass of nitrogen divided by molecular mass of urea into 100. Here total mass of nitrogen is your how much? 2 into 14. That means here I can write 28. Molecular mass of urea means 60. So here I can write 28 divided by 60 into 100. After calculation, you can find 46.67 percentage. Similarly, mass percentage of hydrogen equal to total mass of hydrogen divided by molecular mass of urea into 100. So here I can write 4 divided by 60 into 100. Since the total mass of hydrogen is your 4 into 1. So here I can write 4 divided by 60 into 100. After calculation, you can find mass percentage of hydrogen is your 6.67 percentage. Similarly, mass percentage of carbon means total mass of carbon divided by molecular mass of urea into 100. Total mass of carbon means I can write here 1 into 12. That means here I can write 12. Molecular mass of urea is your 60. So here I can write 60. That means mass percentage of carbon equal to 12 divided by 60 into 100. After calculation, you can find that is your 20 percentage. Similarly, mass percentage of oxygen. Mass percentage of oxygen means total mass of oxygen divided by molecular mass of urea into 100. Here, one oxygen atom is present. Look at that. In the formula, here one oxygen atom is present. So here I can write 1 into 16. That means here I can write 16. Molecular mass of urea is your 60. So here I can write 16 divided by 60 into 100. After calculation, you can able to find 26.66 percentage. So finally, we concluded that the mass percentage composition of urea means percentage of nitrogen equal to 46.67 percentage, mass percentage of hydrogen equal to 6.67 percentage, mass percent of carbon is equal to 20, mass percent of oxygen is equal to 26.66. I will give a trick, all the answer whether correct or not. After addition of each percentage, then you must find it is equal to 100. Look at that. If I will add the all percentage, that is your 46.67 plus, that is your 6.67 plus 20 plus 26.66, then what will be? This must be equal to 100. If this not equal to 100, that means your answer is wrong. This is all about the mass percentage, that is a percentage composition. Next, I will move to the type of chemical formula. Take an example. Suppose I want to take an example, that is your glucose. Suppose I want to find the molecular formula and empirical formula. Here, the topic is your type of chemical formula. Generally, the chemical formula of a compound may be expressed as molecular formula or empirical formula. One is the molecular formula, another is the empirical formula. Suppose I want to take an compound, that is your glucose. Here, I can say that molecular formula is your C6H12O6. But for writing the empirical formula, we have take the ratio of the atoms. Look at that. Here, three types of atom is present. One is carbon, another is hydrogen, another is oxygen. But if I want to say that the number of carbon atom is your 6, The number of hydrogen atom is your 12. The number of oxygen atom is your 6. Suppose I want to find the ratio. That means the carbon divided by hydrogen divided by oxygen. Then what is the ratio? That is your 6 divided by 12 divided by 6. After simplification, I can write here 1 is to 2 is to 1. So here I can write the empirical formula of glucose is your C1H2O1. That means simply you can write CH2O. It is not necessary to write here 1 because for one case it is not necessary to write. Finally, we concluded that the molecular formula of glucose is your C6H12O6, but the empirical formula of glucose is your CH2O. Empirical formula generally related to the simple whole number ratio of the atoms of various elements present in one molecule. But if you think about the molecular formula, that is your C6H12O6, it clearly represents the actual number of atoms of various elements present in one molecule of the compound. That means here I can say that molecular formula, how can I define molecular formula? The formula that represent the actual number of atoms of various elements present in one molecule of the compound is called molecular formula. Similarly, if you want to find out the definition of empirical formula, then the formula that represent the simple whole number ratio of the atoms of various elements present in one molecule of the compound. That is called your empirical formula. Then look at another example. Suppose I want to take another example, then you can able to understand clearly. Suppose I want to know the molecular formula of hydrogen peroxide. You know very well that is your H2O2. Here, two type of atom is present. One is hydrogen, another is your oxygen. The number of hydrogen atom is your how much? Two. The number of oxygen is your how much? That is also two. Suppose I want to find out the ratio H by O. Then what I can write? Two divided by two. That is your one divided by one. I can write 1:1. So the empirical formula is simply HO. Finally, I can conclude that the molecular formula of hydrogen peroxide is your H2O, H2O2. The empirical formula of hydrogen peroxide is your HO. Look at that. Finally, I can conclude that molecular formula means the formula that represent the actual number of atoms of various elements present in one molecule of the compound. Next, empirical formula, the formula that represent the simple whole number ratio of the atom of various elements present in one molecule. Mathematically, here I can say that molecular formula. Look at that. That is here I can write molecular formula. Here I can write molecular formula equal to what? N into empirical formula. Here I can write what? Molecular formula equal to N into empirical formula. Here MF means molecular formula, EF means empirical formula. Then how can you find the value of N? Here I can find N is equal to molecular mass by empirical mass. There is a relation between molecular formula and empirical formula. The relation is molecular formula equal to N into empirical formula. Here N is equal to molecular formula, molecular mass by empirical mass. Look at that. How can I justify here? We know that molecular formula of glucose, that is your C6H12O6. So here I can find the molecular mass of glucose like this. Since here 6 hydrogen atom is present, since here 6 carbon atom is present, so here I can write 6 into 12. Since here 12 hydrogen atom is present, so here I can write 12 into 1. Since here 6 oxygen atom is present, so here I can write 6 into 16. That means totally I can find molecular mass of glucose is your 180. We know that empirical formula of glucose is your CH2O. Recently, I have discussed about the empirical formula. How can you calculate the empirical formula? By taking the ratio of the atoms, you can able to write the empirical formula. Now I will find the empirical mass like the molecular mass. Look at that. Depending upon the molecular formula, you can find the molecular mass. Similarly, depending upon the empirical formula, you can find the empirical mass. Since here one carbon atom is present, so here I can write 1 into 12. Since two hydrogen atom is present, so here I can write 2 into 1. Since one oxygen atom is present, so here I can write 1 into 16. If you will add, if you want to solve this, then the total value is your 30. That means here I can say that empirical mass of glucose is equal to 30. But empirical formula of glucose is your CH2O. Similarly, molecular formula of glucose is your C6H12O6. But molecular mass of glucose is your 180. Now find out the value of N. We know that N is equal to molecular mass by empirical mass. Your molecular mass is your 180. So put here empirical mass of glucose is your 30. So put here. That means here I can write N is equal to, here I can write N is equal to 180 divided by 30. So which is equal to, that is your 6. Again, we can apply this formula. Molecular formula equal to N into empirical formula. Here the value of N is your how much? That is your 6. Now put the value of N in this equation. Here I can write molecular formula equal to 6 into empirical formula. Here empirical formula is your what? CH2O. So here I can write molecular formula equal to 6 into what? 6 into empirical formula, that is your CH2O, that is your we can write C6H12O6. Here we can justify the molecular formula of glucose is your C6H12O6. This is the molecular formula of glucose. Similarly, you can move to the hydrogen peroxide. The molecular formula of hydrogen peroxide is your H2O2. Molecular mass of hydrogen peroxide is your how much? Your two hydrogen atom is present. So here I can write 2 into 1. One is the atomic mass of hydrogen. Atomic mass of oxygen is your 16. Here two oxygen atom is present, so here I can write 2 into 16. That means here I can write 2 into 1 plus 2 into 16, that is your equal to 34. So here I can write molecular mass of hydrogen peroxide is your 34. For empirical formula, we know that the empirical formula of hydrogen peroxide is your HO. It is obtained by taking the ratio of the atom present in the molecule. Now, as per accordingly the empirical formula, I can find the empirical mass of hydrogen peroxide is your 1 plus 16, that is your 17. Now find the value of n. N is equal to molecular mass by empirical mass. Here I can write 34 divided by 17, that is your equal to 2. We know that molecular formula equal to 2 into n into empirical formula. Here the value of n is your 2. So here I can write molecular formula equal to 2 into empirical formula. That means here I can write 2 into HO, that gives a H2O2. So here I can say that molecular formula is justified. This is all about the empirical formula and molecular formula. Next, I want to move to the calculation of empirical formula. There are few numbers of questions, problem, that is your problem. Here I have given. Now I want to solve these problems. All the problems generally related to the empirical formula and molecular formula. How can you calculate the empirical formula? Now I want to follow the procedure. Step 1. Write down the name of the element and the mass percentage. Suppose I want to take this question 1. Here in this question, what is the data given? Look at that. A compound contain carbon, hydrogen and oxygen having a mass percentage of 54.35, 9.07 and 36.58 respectively. Molecular mass is 88 mu. Calculate the molecular formula of the compound. Then what is the procedure? Step 1. Write down the name of the element and their mass percentage. Here molecular mass is given 88 mu. At first I will write this. Now follow the table. In the first column write the elements. In the second column write the mass percentage. In step 1 it is your aim to write the name of element and their mass percentage. So here I can write the element present in the compound. Look at that, the question. In the question, see that a compound contain carbon, hydrogen and oxygen. So the element present here are carbon, another is your oxygen, another is your hydrogen, next is your oxygen. So in the first column I want to write like this: carbon, hydrogen, oxygen. Next, write down the mass percentage. Look at that. Here, in the question, the data is given having a mass percentage of 54.35, 9.07, and another is your 36.58. So I can write here mass percentage, that is your for carbon 54.35, for hydrogen I can write 9.07. Next for oxygen I can write 36.58. So at first I want to write the data in first column and second column. This is step 1. Next step is find the atomic ratio. Step number 2 is your find the atomic ratio. For calculation of atomic ratio, we generally follow this formula. Atomic ratio is equal to mass percentage of element divided by atomic mass of element. That means to find out the atomic ratio, we need the atomic mass of each element. So in column number 3, write down the atomic mass of each element present in the compound. The atomic mass of carbon is your how much? That is your 12. So here I can write 12. The atomic mass of hydrogen, that is your 1 here, so I can write 1. The atomic mass of oxygen, here I can write 16. In column number 3, I can write the atomic mass of each element. Now find the atomic ratio. In column number 4, I want to find the atomic ratio. The formula is your mass percentage of an element divided by atomic mass of an element. Mass percentage of element of carbon, that is your how much? 54.35. Next atomic mass of carbon is your how much? 12. So I can write here 54.35 divided by 12. After solving, you can find 4.53. Similarly, if you think about hydrogen, the mass percentage of hydrogen is 9.07, and the atomic mass of hydrogen is 1. After solving, you can find 9.07. Next, for oxygen, the mass percentage of oxygen is your 36.58, and the atomic mass is your 16. So here I can write 36.58 divided by 16. After calculation, you can find 2.29. For carbon, atomic ratio is your 4.53. For hydrogen, atomic ratio is your 9.07. For oxygen, the atomic ratio is your 2.29. This is up to step number 2. Next, follow the step number 3. This is step number 3. Divide by the smallest atomic ratio to get the simplest atomic ratio. In next step, you are aim to find the simplest atomic ratio. This can be obtained by using the smallest, that is your simplest atomic ratio, that is your smallest. That means in step number 4, you are aim to find the smallest atomic ratio. There are three atomic ratio present. One is your 4.53, another is your 9.07, next is your 2.29. Among the three value, 2.29 is the smallest atomic ratio. So your aim to find the simplest atomic ratio. This can be possible by using the smallest atomic ratio. In this step, you what you want to do? Divide all the atomic ratio by using the simplest, that is your smallest atomic ratio. That means in next step, I can write here 4.53 divided by 2.29. Next, 9.07 divided by 2.29. Next, your 2.29 divided by 2.29. In this step, you aim to find the smallest atomic ratio and divide all the atomic ratio by the smallest atomic ratio. So here I can write 4.53 divided by 2.29, which is equal to 2. 9.07 divided by 2.29, which is equal to 9.96. 2 by 2, sorry, 2.29 divided by 2.29, that is your equal to 1. Next step is the simplest whole number ratio. Look at that. This is an simplest whole number. So here there is no necessary of any change. Here I can write only 2. But if you will think about 3.96, this is not a simplest this is not a simplest simple whole number ratio. It is a fractional value. So I can write the nearest simple whole number, that is your 4. Suppose a value is given like this in 5.01. Suppose a value is given 5.01. Then what is the simplest simple whole number ratio? That is your 5. That means here you can write only 5. Suppose a value is given like 1.12. You can write here only 1. Like that, suppose a value is given 1.5. Look at that. then this is one other type of critical problem. In this case you cannot write 1 or you cannot write 2. In this case you multiply with the another whole number, maybe that is your 2. If I multiply with the 2, that means here I can find that is your 3. This is an whole number, here I can write 3. This is a critical problem. Now, at first, discuss about the simple problem. Then you can move to the critical problem. Uh, Generally, look at come to this problem. Here 2 is given, so here I can write 2. But here 3.96 is given, so here I can write 4. Here 1 is given, so here I can write here 1. So the simple whole number ratio is your, that is your 2, 4, 1. This is up to step number 4. After getting the simple whole number ratio, this is the ratio of carbon, hydrogen and oxygen. So what will be the formula? The empirical formula is your what? C2H4O. 2 related to what? Carbon. 4 related to hydrogen, and 1 related to oxygen. So here I can write C2H4O. This is the empirical formula. Suppose here the value may be 2, maybe 5, maybe 2. Then what will be the empirical formula? The empirical formula must be, I can write C2H5O2. This is the empirical formula. Suppose this is your 1, this is your 3, this is your suppose 4. Then what will be the empirical formula? The empirical formula is your C1 H3, next is your O4. That means here I can write simply CH3O4. As per the simple whole number ratio value, I can write the empirical formula. After knowing the empirical formula, I can easily find the empirical mass. Look at that, 2 carbon atom is present. So here I can write 2 into 12. Since 4 hydrogen atom is present, so here I can write 4 into 1. Since 1 oxygen atom is present, so here I can write 1 into 16. After addition, you can find 44 mu. Again, we know that our aim to find the molecular formula of the compound. Up to this, I already calculate the empirical mass. From the question, we know that molecular mass is your how much? 88 AMU. Now, empirical mass is your 44 AMU. We know that the value of N is equal to what? Molecular mass divided by empirical mass. Your molecular mass is your 880. Next empirical mass is your 44. So here I can write N equal to 880 divided by 44. That means here I can write N is equal to 2. Again, we know that molecular formula is equal to N into empirical formula. The value of N is your 2. So here I can write molecular formula equal to 2 into empirical formula. Empirical formula is your what? That is your C2 H4O. So here I can put this. That means I can write molecular formula is equal to 2 into C2H4O. Next, I can write here C4H8O2. So the molecular formula of the compound is your C4H8O2. This is the answer. Our aim to calculate the molecular formula of the compound. The answer is your C4H8O2. Next, move to the question number 2. An organic compound. having molecular mass 180, is composed of 40% of carbon, and next is your 6.67 percentage of hydrogen, 53.33 percentage of oxygen. Calculate the empirical and molecular formula. Also give a probable name of the compound. As for the procedure, first step is write the data, that is your name of element and mass percentage. As per the question, I can write here three elements. One is carbon, another is your hydrogen, another is your oxygen. The mass percentage data is your 40. Next is your 6.67 percentage. Next is your 53.3 percent, 53.33 percentage. Atomic mass is your what? 12, 1, 16. Now find the atomic ratio. As per the formula, atomic ratio is equal to what? Percentage composition divided by atomic mass. Here carbon having the percent. Here the carbon having the atomic mass percentage your 40. So here I can write 40. Next, the atomic mass is your 12. So here I can write 40 by 12. After solving, you can find the value is your how much? 3.33. This is the value. Here we can write 3 point. This is the value 3.33. Similarly, you can proceed atomic ratio for hydrogen. Here the mass percentage is your how much? 6.67 percentage, and the atomic mass is your 1. So here I can write 6.67 divided by 1, that is your how much? 6.67. Similarly, you can find the atomic ratio for oxygen. Here the percentage composition is your 53.33. The atomic mass is your 16. So here I can write 53.33 divided by 16. That means here I can write 53.33 divided by 16, that is your 3.33. After getting the atomic ratio, find out the smallest atomic ratio. Here 3.3 is the smallest atomic ratio. Next is find out the simplest atomic ratio. Now divide all the atomic ratio by the help of the smallest atomic ratio, that is your 3.33. So here I can write 3.33 divided by 3.33. Next is your 6.67 divided by 3.33. That is your equal to 2. Here the value is your 1. Next I can write here 3.33 divided by 3.33, that is your equal to 1. Look at that. Here the simplest atomic ratio is your what? 1. Next is your 2. Next is your 1. Look at that. All the values are in simple whole number. So next step is the same with the simplest atomic ratio. That means here I can write 1. Here I can write 2. Here I can write 1. This is the simple whole number ratio. As for the simple whole number ratio, I can write the empirical formula. The empirical formula is your what? This is your carbon. This is for you can write for carbon. This is for carbon. So here I can write C1. This is for hydrogen. So here I can write H2. This is for oxygen. Here I can write O1. That means here I can write CH2O. So here you can concluded that the empirical formula is your CH2O. As per the empirical formula, you can able to find the empirical mass. Here, one carbon is present, two hydrogen is present, one oxygen atom is present. So add the atomic mass of each atom, then you can able to find out the empirical mass, that is your 30 mu. Again, we know that n is equal to what? N is equal to molecular mass. N is equal to what? Molecular mass divided by empirical mass. Your molecular mass is your how much? 180 AMU. Empirical mass is your 30. So here now we can write N is equal to 180 divided by 30, which is equal to 6. Molecular formula, we know that that means we can find molecular formula is equal to N into empirical formula. Here I can write molecular formula equal to N into empirical formula. N into empirical formula. Look at that. The empirical formula is your CH2O. So the value of N is equal to 6. So here I can write the molecular formula is your C6H12O6. Another question is given. Give one probable name of the compound. Look at that. We know that glucose having the formula C6H12O6. So the probable compound is your glucose. So here the answer is your what? That is your glucose. This is the question number 2. Next question number 3. A compound is found to contain 64.8 percentage of carbon, 13.62%, 13.62% of hydrogen. Next is your 21.58 percentage of oxygen. These are all in weight. What is the empirical formula of this compound? The molecular weight of the compound is your 74.14 gram per mole. What is the molecular formula? Like problem number 1 and 2, you can easily find out the answer. What is the molecular formula? The molecular mass is your here given 74.17 gram per mole. The elements are your carbon, hydrogen, oxygen. The percentage composition is your here given 64.8, 13.62%, 21.58 percentage. You can write this data from the question. You can write the atomic mass here 12, 1, 16. Next, as per the formula, you can able to find the atomic ratio. The atomic ratio you can find here are how much? 5.4, 13.6, 13.62, 1.35. You can find the simplest atomic ratio. Here, the smallest atomic ratio is your 1.36. So here you can write 5.4 divided by 1.35, which is equal to 4. Similarly, you can write here 13.62 divided by 1.35, that is equal to 10.09. Similarly, you can think about for oxygen. Here, 1.35 divided by 1.35. That is your 1. Look at that. For hydrogen, the value is your 10.09. So, in the next step, I can write here only 10. Here already whole number is present. So, here I can write 4. Uh, next is your one already whole number. So here I can write only one. The simple whole number ratio is your how much? 4, 10, 1. 4 belongs to carbon, so here I can write C4. 10 belongs to hydrogen, so here I can write H10. 1 belongs to oxygen, so here I can write O1, or you can simply O. So the empirical formula is your C4H10O. As per the empirical formula, you can able to find the empirical mass. Empirical mass is equal to how much? That is your 74. By using the empirical formula, you can find the empirical mass. Here n value is equal to how much? Molecular mass divided by empirical mass. Molecular mass is your 74.14. Empirical mass is your 74. So the value of n is equal to how much? That is your 1. Again, we know that molecular formula is equal to n into empirical formula. Here the value of n is equal to 1. So here I can write how much? Here I can write molecular formula is equal to 1 into empirical formula. Finally, I can write C4H10O. Our target to find out the molecular formula. The molecular formula is your C4H10O. For this class, I am stopping here. For next class, I will discuss about the atomic mass, method for determine the atomic mass. The class note are available in the description. Click the link to download. At last, I would like to say, please like, share, and subscribe to the channel, and press the bell icon for notification. Thank you for watching the video. Please continue for the next class. Make today great one. Thank you.